Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about a Leetcode question number 47, Permutations 2. Given a collections of numbers num that might contain duplicates, written all possible unique permutations in any order. So we want to written the all possible unique permutations, and that array also contain what? Duplicate values. Okay. Let us see the example. See here, first we can solve this example, then we can go to the above. Okay. 1, 2, 3. So this is our original array, right? For this array, we can have how many permutations? Usually permutations can be what? N factorial. If it is 3, then 3 factorial is equal to 6. So we can have 6 permutations. Can you understand this? It is a basic mathematics. Now, first of all, I can place this 1 here itself. If I place 1 in first element, 1 as the first element, then I can get 1, 2, 3 as one permutation. Then 1, 3, 2 as another permutation. Okay, if I place 2 at first, then I can get 2, 1, 3 as first permutation. Then 2, 3, 1 is a second permutation. Okay, if I place 3 at first, 3, 1, 2 and 3, 2, 1. So these are the all permutations that we have if the element is what? 1, 2, 3. Right? So these are all unique. So we have written what? Unique elements. Okay, now let us move on to the next example. What is the next example? It is 1, 1, 2. So for this example, I can say, I can place this 1 at first, right? If I place this 1 at first, then 1, 1, 2 can be one possibility, or 1, 2, 1 is one permutation, right? Okay, if I place this 1 first, then 1, 1, 2 is another thing, and 1, 2, 1 is another permutation, right? Okay, if I place this 2 first, then 2, 1, 1, then also 2, 1, 1. So I can say here, duplicates are occurred. This is one of the duplicates, strike out. Then these 2 are one of the duplicates, just strike out. So at last, we have only 3 elements as a unique elements, just return those 3 elements. So this is what the question says, right? Okay. We want to construct a tree such that in tree, we will compute all possible permutations. So see here, we want to compute all possible permutation. Then what is second step? We want a unique elements, right? So to pick those unique elements, what we can do, we can use a set data set, right? We use that set data set. It is easy for me to take whatever we want and to ignore whatever we don't, right? It will only take the unique values. So these are the 2 steps involved to calculate, to attain the output, right? Okay. So how to find all possible permutations? So see here, for example, 1, 1, 2. So this is my array. Now, initially I will take this 1 as a first element, or this 1 as a first element, or this 2 as a first element. Okay, take 1. Here also 1. Here 2. Can you understand this? Okay, now for this one, I can take this 1 as a first element, as the next element, or this 2 as the next element. Okay, take 1 as the next element. Then it will be 1, 1. Here it will be what? 1, 2. Let me put the now. For this 1, I can take this 1 as first element, or this 2 as a first element. So take it. Yes. Now, for this 2, I can take this 1 as a first element, or this 1 as a first element. So take it 2, 1, 2, 1. Fine. Now, again, for this, I can take 2. For this, there is only possible, it is what? 1. For this, there is only possible 2. For this, only possible 1. For this, only possible is 1. For this also, only possible is 1. So I got all possible permutations. Now I will take what are the unique elements, because we are just putting into a set data set, right? We are just putting these all individual array or list inside our set data set. So we will get what? Those unique values. So I will get 1, 1, 2, then 1, 2, 1, then 2, 1, 1 as our answer. So hope you understand this. Okay. What is the time constant for this? I can say my time constant will be O of, first of all, we are computing all permutations, right? To compute all possible permutations, it will be n factorial, because we are in each level, we are picking what? How many times? We are picking n times. That's why. Okay. Now, into, we are just using a set data set, and inside that set data set, we are using what? A n length of array, and n length of array. So it will take to n. Then what else? To push into a set, it is not a constant operation. It also take what? At the most case, it will be log n. If the set contains n factorial, then it will be log n factorial. So this is going to be my time complexity. Now, what is my space complexity? It is O of n factorial. Now, you may ask, See here, this is a recursion. This is a recursion tree, right? Here, I will get only the n times, right? Recursion is always what? DFS. And one more, if you don't understand this recursion tree, go to my permutation video and see this whole recursion tree concept and come to again this problem. Can you understand this? And I will give the link in the description. So by watching the permutation, you can understand what I mean. What is mean by backtracking here and why I am getting the recursion stack at the most value as n or at the most length as n. Okay. Now see here, this DFS, right? So it only have the recursion stack of value length is equal to n, right? Apart from that, it won't go. But we are just pushing each and every value into our sector register, right? If take for example, all are unique value, then what will be the space of that set data set? It will be n factorial. And understand this? That's why our space quantity will be what? N factorial, and our time quantity will be this. Okay. Now, can we optimize it? Because if we don't have this space and also some modification in time, it will be more optimal, right? Okay, let us optimize it. Okay, can we do this without the set? Then only the space and time will be optimized, right? Okay, let us carefully observe wherever it is repeated or which causing the duplicates. First, we want to find which causing the duplicates. Okay. Just observe this. Wherever the duplicates are found, first it is found in 1, 1, 2 and 1, 2, 1. While here also it is same, right? So this is our first place where we found that it is a duplicates, right? Okay. Now going to the up, see here, this level is also same and this level is also same. So I can say this one and this one is same. So if I ignore this one's recursion call, is ignored, then I can say this whole recursion will be ignored, right? And we cannot generate these answers. Okay. Now this 2, 1, 1 and this 2, 1, 1 is repeating. Okay, going to the next level. Now these two are same, right? But it is okay. This 2 is okay. Because of this 2 only, we have this 2 recursion call. But if I don't have this recursion tree, this recursion subtree, then I can say I only get a unique value. Can you understand this? Okay. What is the logic behind it? Every time we are taking what? Either 1 or 2 here. Okay. Here also, either I am taking 1 or 2 here. Here also I am taking either 1 or 2 here. Sorry. Here I am taking 1 and here I am not taking this 1 again. Here I am not taking the 1 again. So from this I can say, if I took a same element in the previous step or previous recursion, now I am not taking it, right? So this can be also written as, just see here, if I have a count of 2 as 1 and 1 as 2, just take for example, this is a count, right? Now I can only take either 1 or 2 now, right? Can you understand this? Yes, we only take 1 and 2. Okay, 1 and 2 only we are taking now because of this count. Now we want to take this 1 and 2 up to what? Up to this count. Can you understand this? Okay, now let me consider the recursion tree so that it will be more clear. See here, initially what is the value? It will be, initially what should be my function? My function should contain auxiliary space to store these values, right? Okay, and may contain auxiliary space, right? So let me take the auxiliary space as empty initially. Okay, now at first recursion, either I can take 1 or I can take 2, right? Okay, first I take 1. Okay, I took 1 or take what? 2. But just observe whether our recursion call goes like this. No, right? Because recursion call is not BFS. It is what? DFS. It should complete whole depth, then it comes. Okay. So we cannot go like this, right? We cannot go like this. Now, let me ignore this. Now, what is our count? It will be 2 is 1 and 1 is 2, right? Now, I took 1 already. So it will be reduced to what? 1. Can you understand this? Okay, now, again. For this 1, I can take either 1 or 2, right? Okay, take 1. If I take 1, it will be 1, 1. If I take 2, it will be 1, 2. Right? But unfortunately, we cannot do like a BFS. We can only do like DFS. Okay. Now, I took 1. So, I will remove this 1 again. So, it will be 0. It will be 0. Okay. Now, whether I can take 1? No, 1's count is 0. But 2 count is that. So, I will take 3. It will be 1, 1, 2. So, and this 2 count will be what? 0. Can you understand this? Okay. Now what should we do? We should backtrack because we got the length of what? Length of 3, right? So this should be my answer and we should backtrack. Can I understand this? Why we are backtracking? Okay, backtrack. While backtracking, what should we do? We should pop this 2 because initially we just put this 2 inside, right? Now it's time to put the 2 outside. If I put the 2 outside, my count will be restored as what? 1. I'm doing what? Just plus 1. Initially I done -1 before the recursive call. Now it's backtracking. So backtracking, I will put +1. Now it is backtrack. Now I took 2, right? Anything else I want to take? No. So it also backtrack. Okay, backtrack. While backtracking, I should remove this 1. Okay. If I remove this 1, it will be 1, right? Will be 1. Okay. Now I successfully finished for recursion call for 1. Now it's time for 2. If I take for 2, 2 count will be 0. Then again I can take only what? 1. Take it. If I take 1, it will be also 0. Now I got a length of what? 3. So this should be my second permutation. Okay, now it's time for what? Backtrack. So backtracking. So this 1 will be cancelled out. And this will be what? Count will be increases 1. Here also. Again it will be backtracking. Okay, so this 2 counts will be what? 1. Okay, now for 1, I took 1 and also 2. So it's time for backtrack. While backtracking, this 1 will be removed and this 1 count will be 2. Preserved. Initially it will be preserved. Okay, now what's the next possibility? I took 1. Now it's time for what? 2. Take this 2. If I take 2, my 2 count will be 0. My 2 count will be 0. Now I can have only one possible way. What? I can take only 1, right? Okay, if I take 1, my array something looks like 2, 1, 2, 1, and this 1 count will be 1, right? Okay, again, it will be 2, 1, 1. This 1 count will be 0. Can you understand this? Okay, now, what is my array size? It will be 3. Now, it should be my answer. Just put it. Can you understand this? Okay, now, it's time to backtrack. While backtracking, what should we do? We should pop this 1 now. If I pop this 1 out, it will be what? 1. Again, backtrack. While backtracking, I should pop this 1 out. So, it will counter as what? 2. Now, I should backtrack. So, this 2 count will be what? 1. Can you understand this? And then, we took 1 and also 2. Whether we have anything else? No. So, stop here. Now, see what are the outputs we have got? We have got the outputs as 1, 1, 2, 1, 2, 1, then 2, 1, 1. So can you understand this? So in this, what we have done for attaining the unique values, we are taking only the unique values. Can you understand this? To attain those unique values, we want to take what? Only the unique values. By taking those unique values, I mean, we want to take the unique values in our recursion call, but we want to take the count in our mind. Not to take the count also. Can you understand this? In permutation 1, all elements are unique, right? That's why we are getting what? A unique element as a result. But here it is duplicate elements. So we want to take what? Only the unique values. That's why I am using what? This dictionary data set. Okay, or hashtag data set. Fine. Now, let us see the code so that it's more clear. See here, first of all, n is equal to ln of nums. And I am putting everything into my dictionary. Now, result is equal to just say empty list. Now, def permutation of auxiliary. If length of my auxiliary is equal to my nums, then what should I take? I should take the copy of my auxiliary. Why I am taking a copy of the auxiliary? I will tell you. Then I will return it. Okay, now for in d dot keys of. So I am taking the 1 by 1 values from my dictionary. Then d of I is greater than 0. If my d of I is greater than 0, this means what? If my count of that particular element is greater than 0, then what should I do? I should reduce 1 in the count, and also I want to append the value, not the count. I want to append the value in our auxiliary space. Okay. Now I will call the recursion. And while backtracking, what should I do? I should increment my count by 1. Then I should pop that value which I recently added. Now at last I am calling the permutation function. Then I am returning the result. Let me submit it. Yes, it is submitted successfully. Now let me take this copy of function away. Okay, let me take it. Now, let me run this code so that you can know what is the output. Now, see here, what is the output? It is an empty list. Why? Because while I'm backtracking, what will be my auxiliary space? It will be again goes to what? An empty list, right? That's why when it's finally output is empty list, what is the output we got? We will also get the empty list. That's why we want to take a copy of the auxiliary. Can you understand this? That's why you want to take the copy of the auxiliary and store it into our result. That's why I'm saying that we want to do this copy of and it is so much important. Now it's time to see the time complexity and space complexity, right? Okay, so the time complexity will be what? O of, first of all, we are generating all possible permutations, right? For that itself, in worst case, we will get what? N factorial into, we are pushing length of 3, which is what? Length of n into our data set, right? Which the resultant data set. So it will be what? Into n into, we are just iterating to what? Iterating to the dictionary elements. To access the dictionary elements or pushing into dictionary elements like that. So it will take what? Log n times. It is not log of n factorial because we are only storing what? At most n elements in our dictionary. Why all elements count is 1. Okay. And what is space complexity? I can get my space complexity as O of n. So see here, it is quite optimist, right? The space is mostly optimist. Can you understand this? So why the space is n? Because I will tell you clearly, here the stack space will be 1, here it will be 2, here it will be 3, here it will be what? 4. Then again when it backtracks, it will be cancelled out. Then while it backtracks, it will be cancelled out, and it will be considered as 3, then it will be considered as 4. Can you understand this? This is our stack space. Here 1, 2, 3, 4. While the backtracking, this will be cancelled out. This will be cancelled out. And again when I put anything else, it will be what? Stack space of 3, right? Then if I put anything else, it will be 4. Then while I backtrack, it will be cancelled out each and every time. Can you understand this? That's why our space complexity is O of n. Can you understand this? Thank you.